All right, so now the last thing is applications and finding the area of a triangle. Now, if you notice, when you're doing the area of the triangle, it's the area of the base times the height. And so here, if I know angle A and I know side B and C, say, I can figure out the height because I have the base, okay, and I know angle A, and so notice the height would be, the sine of the height would be, or the sine of A would be the height over C. And so that gives me this formula, 1/2 the base, and then C sine of A would be the height. I can also, if I know side B and side A, I can use angle C, and so that gives me this formula because the base is still B, and then A sine of C gives me the height. So here's A sine of C times the base. And then if I dropped a different perpendicular, then I could do this with angle B. So here are the three formulas that you can use for the area of a triangle. And notice it's always the two sides and then the angle that's included between them. All right, so here it says find the area of the triangle, and I'll just go ahead and draw it. So the angle here is 102 degrees, and then this is 90, and this is 52. And so notice this is my height, but still the height is going to be the sine of this reference angle, which would be the same as the sine of 102. And so I'm just going to use the formula. Area is equal to 1/2 AB times the sine of C. So this would be 1/2 times 90 times 52 times the sine of 102 degrees. And so that's 90 times 52 times the sine of 102, and then divided by 2 equals 2288.87 if I round it off, because the number after the 6 is 5 or bigger, so it rounds up. And so that would be the area of that triangle. Now the next application that we'll look at is finding an altitude. All right, so when I'm finding an altitude, let's say that we have a plane that's taking off from an airport, and they have two satellites here and here, and they're marking the elevation of the plane. So we're looking for this distance here. And let's say that these two satellites are 20 miles apart. And when it's looking at this plane, the angle of elevation here is 15 degrees, and the angle of elevation here is 35 degrees. And remember, angle of elevation is always from the horizontal going up. From the horizontal going up. All right? And so what I'm going to do first is I'm going to find side A. So let's call this A, B, and C. All right? So I know side, and what I'm basically going to try to find is this height H. But before I can do that, I have to find either this side or this side. So first I need to find out what angle B is. So again, the angles in the triangle add up to equal 180 degrees. And so this would be 50 plus b is equal to 180. And then subtract the 50. And we get b is equal to 130. All right. And so now I know what angle B is. And so now I can use my law of sines. So this would be, if I'm looking for A, it would be A over sine A equals B over sine B. Okay, so this would be A over the sine of 35 is equal to 20 over the sine of 130 degrees. Okay, and then multiplying both sides by sine of 35 over 1. Over here they cancel, and I get A is equal to, so I have 20 times 35 sine divided by 130 sine is equal to 14.975. So that's what side A is. Now, but that's not what I'm looking for. I want to know the altitude of the planes. I'm looking for this height h. So what I'm going to do is I'm going to take this triangle, now that I know what A is, and I'm just going to drop that perpendicular, and I'm only taking this half right here, this half of the triangle. So here's C, and this is 15 degrees. Here's H, and now I know that this is equal to 14.975. And so now I do have a right triangle because this is the perpendicular height from the base here. And so now if I look, I'm looking for the opposite, and I know the hypotenuse. So that would be the sine of theta is equal to the opposite over the hypotenuse. So the sine of 15 degrees is equal to h over 14.975. Then multiply both sides by 14.975 over 1. And so here it cancels, and I get that the height of the plane is equal to 14.975 times the sine of 15 is equal to 3.8, and if I round it off, 8 miles. So it's approximately 4 miles up in the air. And so that finishes off the part on applications for section 10.1.